Okay, the clock has just turned a little over, a little over one. I'm looking at some of the comments that are floating in. Yes, a lot of interest in the soccer game. But before that, let's talk a little bit about numbers. So my name is Anish Banerjee. I'm with the Faculty of Management at the Business School, soon to be called Bayes Business School. And it's my absolute pleasure and privilege to invite Tom for our discussion today. As I'm sure all of you know, the topic of conversation is clearly Bayesian thinking and storytelling with numbers. And perhaps Tom is absolutely the right person to tell us a little bit more about how numbers are often used not only in journalism, but in other fields as well to tell a story. But before we jump into Tom and his most recent book, I want to remind everyone about the next two talks that are in the pipeline. The next one, which is on 14th of July, is all about building the future of higher education, and with our new president, Professor Anthony Finkelstein, and it will be hosted by Netra, who's my colleague from the Faculty of Management. The one after that is on 21st of July, and that's also a little bit about, not a little bit, that is about Reverend Thomas Bayes, life and legacy of Reverend Thomas Bayes, and that will be with the biographer of Bayes, Professor David Bellhouse. So please do pencil those two down in your calendar as well. Without further ado, let's introduce Tom. He may not need an introduction for most of you. He is a very well-known London-based science writer. He has worked with the Daily Telegraph for quite some time. He was a science writer at BuzzFeed, and now, of course, he is the science editor at Unherd. He has received several awards in journalism. Of course, the most interesting one of course, is called Explaining the Facts. It's a category honored by, of course, the Royal Statistical Society's Statistical Excellence in Journal Awards. Yeah, quite a mouthful, but clearly you can see, that his work has been recognized by the Royal Statistical Society as well. Yeah. Interestingly, Tom has an undergraduate degree in philosophy from the University of Liverpool, and he has a master's degree from King's College London Center for Medical Law and Ethics. Yeah. We are here, of course, to talk about Tom's second book. The first one is also very interesting in case your curiosity is piqued already. The first one was The Rationalists, Artificial Intelligence, and the Geeks Who Want to Save the World. The second one is clearly How to Read Numbers, a guide to statistics in the news. Yeah, and that's the one that we want to talk about today. Tom, in right before we started our conversation, we were just talking about it. Clearly, you're a great communicator, and one of the things that I was thinking about when I was reading a book is a little bit like this, which is perhaps this is just the right time to talk a little bit more about how do we read and interpret numbers. So tell us a little bit about what is going on in your mind, why this book right now. Clearly, a lot has been written on these topics already, but also specifically from a timing perspective, why right now?
Sure. Well, I suppose I should say I wrote it with my cousin David, who's an economist at the University of Durham, a lecturer in economics there, and we realised we were grumbling to each other in our Twitter DMs an awful lot, sort of saying, "Oh God, the story again. Story in the news. Look, they've just given relative risk. They haven't given a denominator. They're all this sort of you can't use this. This gives us no information." We're saying someone should write a book about this, and then realised that we were probably quite well placed to do it ourselves. And you're right. The timing has been. Extraordinary, really, because this last year it has been really important to know about risk and statistics and numbers. It has been the just absolutely vital to it's been a year and a half ago. I write about these things for a living, and I would have struggled to define what the R value was, and now I suspect a double digits percentage of the population could give you a really good technical explanation of it. So things have definitely, it's definitely been the time to learn about what numbers are and how they work and all these things. But it wasn't what we started out thinking about. I cannot remember the exact story that triggered our grumbling in the Twitter DMs, but when we pitched the book in sort of January, February last year, COVID was on the horizon and we could see it coming, and we mentioned it in the proposal, but it wasn't a central theme of the book, and it very much became it. But even pre-COVID, I think we wanted to say that statistical literacy is really important for everyone who wants to participate in the, the democratic life of the country, really, or, any sort of public sort of life at all. Because, just as when we draw a parallel in the book, I think, to in the 1860s and 1870s, when the franchise was expanded to a much larger group of people, more people were able to vote, and people realized that very few people could read, and that was a real problem because they couldn't, read what the government was doing and therefore make informed voting choices. And so there was this real drive, partly driven by that, to expand literacy and education, leading to sort of educational reform acts around that period. And I think that now, maybe always, but especially now in the last few years, you can't, it's important to be able to read, but it's almost as important to be able to understand the numbers that the news is presented in. There's, if you want to know about what, if they say the economy has grown, or if they say, the crime has gone up or down, or schools are doing better or worse, or anything, it's numbers at heart. And if you can't get some grasp of how these numbers are made, you're not going to be able to do a very good job of interpreting what they mean, and therefore voting appropriately, or sort of engaging in democratic life generally. And we wanted to say that, firstly, it's really important, but also that statistical literacy isn't the same as being good at maths, being good at mental arithmetic, right? You don't have to be able to divide 2068 by 43, because you can do that in your browser bar or on your phone in a second. It's fine. That's there for you. What you need to be able to do is ask, how is this number got to me? Where does it come from? Does it tell me what it seems to be telling me? How was it made, and are we using the right one? I mean, the example we come back to often is, it's a bleak one, but the COVID deaths. Should we? You see this stark number, X number of people have died, but that is usually we're talking about the people who died within 28 days of a positive COVID test. Is that the right one? Should we instead use excess deaths? Should we instead use number who die on with it mentioned on their death certificate? These are all different things, and none of them is the right one. The point is, you have to know that which one is telling you what different ones tell you. Yeah. And so it's about asking these sort of questions. It's more of a sort of philosophical or conceptual thing. How should these numbers? What questions should we ask about these numbers in order to get them to make sense? So it's things like, in the book, one example we use was there was a story in the Telegraph from 2018 about children being born to older men had an 18% higher odds of having seizures compared with youngsters with fathers aged 25 to 34, and that sounds bad. 18% sound, higher risk. That sounds bad, but that's what's known as the relative risk. Your risk has gone up relatively by 18% more than it was before. But what the story didn't tell us, and it took some digging out, was that the absolute risk, or how much it actually was, that younger fathers, children born to younger fathers, had a 24 in 100,000 chance of having seizures, and children born to older fathers, had 28 in 100,000 chance. So your absolute risk, the change in your absolute risk, is 4 in 100,000, and maybe that's enough to make you change your opinion about, live your life differently, have children earlier, that sort of thing. But without that absolute risk, the 18% number is meaningless. It tells you nothing. So we are trying to so the idea of the book is sort of show people that these numbers go wrong in these ways. These are common failures. So the book is sort of divided up into chapters where we sort of say things like, how do the numbers get to you because is the sample size big enough? Is the sample skewed? Is it a big number? Is a question we want people to ask a lot. If someone says 75 people with, I don't know, blue hair have died of pleurisy this year, is that a lot? How many people with blue hair are there? How many people would we expect to die of pleurisy from the background rate of the population? Are we, then other questions, maybe a bit more sort of on the scientific end. Is this number representative of the literature? If a paper, one of the examples we regularly talk about is the alcohol and health. There's a story comes out every week. Red wine this week is 2016. 1 glass of wine a day raises the risk of cancer.
I love that example.
Yeah, exactly. One glass of red wine a risk slashes men's risk of prostate cancer, or is good for the heart, isn't good for the heart, and what it might sound like that is just arbitrarily jumping around, but what we say is, look, okay, that is what you need to do is look at it in the context of the wider literature, and the is if you add this new study to the wider data point, to the many data points you already have, does it shift the opinions very much? And probably not. You shouldn't leave them entirely out of context. And I saw someone in the comments just saying statistical, what was it called? Survivorship bias. Yeah. And that's exactly another thing, that the stories that the number, well, survivorship bias is such a fascinating thing, because it's how numbers go wrong in the first place, but also the stories that get to you in the news they are examples of scientific papers that have made it through the journal process, and so they will be the ones that have found positive results and are statistically significant, and then will be interesting enough to get through to the newspapers. And so there is a survivorship bias problem, that the most interesting things are the ones that get in the paper, and the most interesting things are often false. So that was our idea of the book. It was just to sort of give readers the tools to sort of ask the questions that could help them assess a number or that they read in the news. Is that likely to be trustworthy? How might it have gone wrong? What do I need to look at? And then on the end, we stuck this thing that we rather grandly titled the Statistical Style Guide, which was a list. It was a guide more for journalists, but we would love readers to get involved with it and sort of say to outlets, this is the sort of thing you should be doing. Which was saying to journalists, look, this is what you should do if you want to improve your statistical literacy, make it easier for readers to navigate the world with using your stories, and that things like giving the absolute risk rather than just the relative risk, or making sure that you give the context, making sure that your study is representative of the literature, making sure you correct any errors when you make them, that sort of thing. So that was the idea of the book. I've probably ranted on for long enough now, but no. I hope that sort of gives a sense of what we were trying to do.
Absolutely, it does. And Tom, you may or may not know that we actually run a module for our undergraduate students called Critical Thinking in Business. And that's exactly what we try to teach them. Really, how do you think about thinking, and how do you think about numbers and interpreting them? So sounds absolutely fantastic. Your last section, I wanted to come to that part last, of course. I will, of course, ask you. I'll, of course, ask you to give us some tips. But I also wanted to remind everyone who has joined us, and thank you for all your questions that are coming in and comments that are coming in. If you have questions for Tom, please do put it in the Q&A as well. Yeah, and clearly the whole idea of these is clearly to have a conversation. Tom, let me start up with something which I find very common, which is, of course, sensationalizing headlines. And in a business school, I'm sure you know, we thrive on slides. And we often have titles on our slides which are quite akin to headlines for journalists, I assume. And one of the most common mistakes that I see students making is, of course, mixing up correlation and causal relations, and making a causal claim when there is none to be had over here. What are your thoughts on this? Why is this so common? Why do we fall prey to this mistake? And how do we avoid it?
Well, it's amazingly hard, isn't it? We're extremely good as humans at spotting patterns, because it is useful to be able to sort of, you notice, I don't know, the classic examples, you notice a shape in the bushes, and if you think it's a tiger and run away, and you're wrong, that's not that terrible. If you don't think it's a tiger and you don't run away, that could be quite terrible. So we are really highly wired up to spot patterns and spot things in the ambiguous things as patterns, and I think that is really what a lot of what is going on. And then and so if you see two numbers going up at the same time, we're very quick to assume that is what the one causes the other. But actually, because there are, the classic example, and we go into it in the book, is that if the ice cream sales and drownings go up on the same day, do drownings, does ice cream make you drown? Probably not. Obviously the two are correlated to a third factor, the heat of the day, how warm it is. And the trouble is in the media, you are often reporting on scientific studies, and the scientific studies will often say, look, we have found this correlation between X and Y. And journalists aren't always brilliant at sort of realizing that doesn't necessarily mean that X causes Y. And they will report, there was an example, fizzy drinks cause violence, said lots of headlines. Fizzy drinks cause violence, it's marvelous, right? And the study hadn't said that. The study had said that people who drink fizzy drinks more are more likely to be violent. Now you could imagine all sorts of like possibly the heat of the day again, like if people are drinking more fizzy drinks because it's hot, and then we also know that murders and violent crimes go up on hot days. There are all sorts of other possible confounding factors rather than Sprite or Fanta makes you go out and stab people. It just seems less, it seems less likely. So what that is something we say a lot in the book is that just if you see this causal language, if you say X causes Y in a newspaper headline or a story, just be wary that maybe the journalist has misinterpreted that and has made a causal connection when there actually isn't one. It is very hard to avoid because we're wired up to look for those things. But I think often there is just sometimes things go up and down together, and there's some more complicated reason for it.
Right. It's almost like a philosophical position that we as readers, we often want to believe that there is a connection between fizzy drinks and being violent. Perhaps we know that fizzy drinks may not be good for us. That's very interesting. There are two sets of questions that are coming up for you, Tom. One is mostly around educating or training journalists around best practices, so to speak, and is there a need for it? And the other one, perhaps, is kind of related, is really what is the correlation between statistics and the truth, especially as it is shown in the news. We're all consumers of news. So really, as consumers of news, what is the relation between statistics and truth? So I know these might be correlated in some way, but what are your thoughts on these two?
So the correlation between statistics and truth is complicated, right? I know there's that famous saying of lies, damn lies, and statistics, and yes, and there's all these things. But there is another saying which I like more, which is, while it is easy to lie with statistics, it is even easier to lie without them. You can if you are using real statistics, then you can make them sound like they're telling different things, telling a different story to the one that they should be telling, the real, but they at least anchor you to some real point in the world. If you say 75 the people with blue hair have died of pleurisy, then assuming that is actually a real thing that happened, then that does give people reading it a starting point to go and examine and find out the truth. They could then say, oh, that sounds bad, but what is the what is the background rate? How many, it allows you a way into, and if you are careful with them and you're using them, again, another state, if you there's the old saying about, people using statistics like a drunk uses a lamppost more for support than illumination, and you can use them like that, but you can also, like this, if you are careful, you can go into the data sets and say, okay, I found this correlation. Is that enough to make me think there is a causal relationship there? Is there is that a bigger number than I would expect given the background rate and all this sort of stuff? And so I think the correlation between statistics and truth is necessarily loose because there are so many degrees of freedom for the people choosing the statistics they use to tell the stories they want. But there is a connection, there is a correlation, and if your goal is to go into them to tell the truth and find out honest things, or even if you are using them to try and find out whether someone else is using them dishonestly, there is a correlation there. Whereas I think the correlation between no statistics and truth is probably rather looser. You can say anything you like with no statistics, and that is complicated. I can't remember what the other question was. I'm sorry. Remind me of that one.
So the other question was about training journalists. But before you go into the other one, Tom, reminds me of a famous quote by Ronald Coase, who once said that if you torture the data long enough, it will confess. You can find it's absolutely fascinating. So the other question was,
the thing is, but the thing is, right? Okay, so that links to the training journalist thing. I think this is because the torturing data, that's not journalists' fault usually. That's the problem is upstream of journalism. A lot of the time, we talk about this in the book, is the with the scientific community, right? The p-hacking problems of people hacking up data and getting to make sure they get their statistical significance of p less than 0.05, and doing it by analyzing in hundreds of different ways, or running the study 50 times and only reporting the one that finds something, and or just excluding it. The whole incentive structure in science is to find these apparently real results, these statistically significant results, and not reporting the things that don't. And I think that is a gigantic problem well upstream of journalism, and then it's really hard to say to journalists, well, you should have known that this, that back to survivorship bias, there's this gigantic publication bias showing, in which really skews all data. You should have known that this study finding, that the Brian Wansink stuff about food, many more to impress women, that sort of thing. That was this really famous study that went around for a while. It turns out it was p-hacked to hell, and there was nothing behind it. And that it's not journalists' fault they reported on that, because they were reporting in good faith on a peer-reviewed study that was published in in major journals. So I think there is, there's a big thing of science needing to get its house in order on a lot of these things as well. But then, yes, I think it is. I would love it if there was a bit more sort of baseline statistical literacy just among journalists who I want to defend journalists here. I think they are, broadly speaking, decent people who want to inform their readers, view journalism as a public service on the whole, and are generally pretty smart, but not all of them are supernumerate. And that can be a problem. And it is often asking knowing what questions to ask, like what is the denominator for this? Is this a big number? What is the absolute risk? Are these questions that I'm, is this scientific study p-hacked to hell? How would I know? So yes, I think there's a lot of problems further upstream in how the numbers are made by the scientific community that is not, I wouldn't blame journalists for, but by the time they get to journalists, I think it would be really helpful to have them know more. Just sort of like exactly the stuff I'm talking about. These are some fairly simple questions to ask that will let you interrogate it a bit more and stop you from putting out misleading stuff advertently or inadvertently.
Yeah. Thank you so much, Tom. So there's another set of questions that's coming on around the business of journalism, so to speak. It's also, to be honest, even in my field, in education and research around different areas of business. There is clearly a whole lot of discussion around what are the incentives for us to actually go to the depth of the truth, and going back to that philosophical point about truth. So similarly, in the business of journalism, are there really any checks and balances in purely from a competitive point of view to actually incentivize journalists to go find the truth, so to speak?
I mean. As I was just talking about, if my defense of journalists is basically decent people, there is a problem that journalism is a business, and it's an attention business. It's an attention economy. Your business will make money if it gets eyeballs, clicks, things, and that those incentives do not correlate perfectly with the incentives of truth seeking. That is a problem. It's a problem in every. It's a problem in science. It's a problem in academia. It is a wider problem that our incentives do not line up with the incentives for making a good world. But as for whether there are checks and balances, the trouble is that it depends on the individual outlet, doesn't it? So there are in some outlets they'll be very, very cautious, very, very careful, saying, well, we can't run this because we haven't got the second source. We can't run this because I don't trust the numbers, And there are others that are going out to make a headline. And I don't want to sort of overstate the difference here. That there are good journalists and bad journalists at every outlet, and there are good everywhere it does good work and everywhere it does bad work. But the checks and balances are often internal. I think there are some sort of external checks and balances in that if you publish stuff that's obvious nonsense, it will get picked up by readers. There are lots of journalists, I've done a lot of it myself, who do what you might call debunking, going out and checking the numbers and saying, well, this doesn't make sense given the context. The people like More or Less on Radio 4 who do fantastic, someone phones in and says, this number doesn't make sense, can you investigate it? And they go and check. And so there are these sort of external groups like that who do, who Ben Goldacre used to do a lot of it years ago. Yeah. So that and social media, Twitter will say, well, this number makes no sense whatsoever. So I think there are checks and balances. There's nothing institutionalized, and I'm not sure how you would make an institutionalized fact-checking system that doesn't let you publish unless you're absolutely right, without utterly hamstringing journalism as an industry and as a democratic check on our leaders and things. So it is complicated, but the checks and balances are not perhaps as explicit as or robust as some people would like.
Yeah. Before we go into your top tips for writing and checking our own writing, and of course reading other people's writing, I want to ask you about Bayes' theorem, of course, which you have dedicated a chapter in your book clearly on Bayes' theorem. Tell us a little bit more about specifically with so much of data that we have all around us today, especially so much of prior knowledge that we have around different topics. Why should we all be a little bit more familiar with conditional thinking or conditional probability and Bayes' theorem, if we want to make it a little bit more technical?
Yes. So I think this is exactly the example of where it's been of something relatively, I called it obscure in an article recently, and I got in loads of trouble because loads of people saying, it's not, this is about as unobscure as a statistical theorem gets, which is sort of fair enough, but anyway, it was not super. Most people do not know what Bayes' theorem is, but actually it is explained and knowing about it would have made the pandemic make a lot more sense over the last year. So it's things like if you have a 99% accurate test and you get a positive result on that 99% accurate test, does that mean you're 99% likely to have the disease? And the answer is no, because if you ran that 99% positive test on 100 people and none of them had the disease, you'd get one person one false positive, and so even though there's none of the disease there, so your chance, if you got the positive result of having the disease, would still be 0%. And then if you'd ran it on 1 million people and only 10 of them had the disease, then you get 10,000 false positives and 2 real positives. So knowing how useful this test is entirely depends on or how accurate this test. It depends on the prior probability of someone having a disease, and that is really counterintuitive, and it throws people in all sorts of situations. In the book, we talk about examples in law of people doing DNA tests where they only go wrong one time in 3 million. But then if you've tested the entire population of the UK with it, you get 20 false positives and 1 true one, and so your chance of getting the right guy just on that evidence would be 1 in 20. And this is really, it feels really backwards and it feels really hard, but it is incredibly important. I think I'm actually fascinated by Bayes because there's this sort of wider move in science to stop using statistical significance as a criterion for assessing whether something should be considered real, and start moving to Bayes factors and sort of assessing prior probability of whether we believe something, and then updating it with each new paper. And I think that's really interesting. There's also what I can't pretend I've begun to get my head around this yet, but there is a large part of neuroscience which argues that all of our brains run as Bayesian systems, updating on new information on prior things. And so I find it an absolutely fascinating topic and actually want to go and write much more about it. But just very specifically on the pandemic, it had this really profound issue because people were baffled by how these you could get large amounts of false positives off this off apparently very specific tests, and if you didn't understand the Bayes theorem and conditional probability, it would have made no sense to you. How can it be 99% accurate and yet be getting it wrong in 30% of cases? So yes, I think would have been a really good time to know about Bayes.
And of course, and I can highly recommend your chapter on that, which I thought was absolutely fantastically very well written, and you clearly are a great communicator on that topic. Yeah. So on that note, Tom, in the last 1 minute, what are your top tips when it comes to writing about statistics that we should all follow?
Well, I've mentioned I've mentioned a couple of them. So I think the really big one is to put numbers into context, to ask yourself, is this, this number is a big number. In our style guide, we give this example that Britain dumps 6 million tons of sewage in the North Sea each year, and that sounds pretty bad, right? But what number do you need to know whether that's a big number? And it's relevant to say that the North Sea contains 54,000 billion tons of water. It doesn't make it all right, but it's the sort, you need these numbers to sort of be able to navigate the world, to make it sort of make sense. We are really keen on absolute risk rather than simply relative risk. The example we gave earlier, if you just say that someone's risk goes up by 20%, firstly, there's a lot of people will misunderstand that and think it means it goes up by 20 percentage points. And so, oh my God, my risk of kids with seizures is 18% or 20%, and that's not how it works. It goes up, but also, unless you know what, 18% more than something is totally uninformative, 18% more than what? And so you need to give, okay, your risk originally was 24 in 100,000, now it's 28 in 100,000. That's the sort of number that people can actually use to navigate it. We are really keen on people being aware, we think it's a lot to ask journalists to say, to run funnel plots or whatever and be able to interpret whether there is, a study is p-hacked or the victim of publication bias or whatever. But we do think it's worth being aware that these are problems and that there are things to be, there are things to be aware of, and that no one study is the last word on anything. I think that's really important. There is, you try and give the sort of to say whether the study is representative of the literature which it's part of. So, one study saying that red wine will, give you cancer, or one study that's saying that fish fingers cause flatulence or whatever, I don't know. It does on its own means nothing. As part of a sort of gestalt, as a larger body of work, then it's something. So you need to explain this isn't a breakthrough. It is an addition to a body of work, shifts our opinion somewhat. You need to give the sort of consensus of that body of work. And that's one thing that's really, really important, is beware of cherry picking where you start your data series. So there was one thing, like there was an example that I wrote about, I think in 2019 or something like that. Someone wrote about suicides have nearly doubled since 2010, and you looked at that sounds really bad, among young people from a certain age group, and that sounds really bad. But then you realize, firstly, they've picked that age group because it's the only one that's changed and the numbers are so small that they jump around a lot, and secondly, they picked 2010 because it's the lowest year on record, and you could pick literally any other year and paint and draw whatever picture you like. So if they'd wanted to say suicides had gone down from 1997 to 2010, they could have done that. Or it was just your story, where you start and finish your data series is really important. And if you are trying to be honest about it, you have to try and do other than simply cherry picking the one that makes your story sound as dramatic as possible. I'm aware that's more than a minute, so I'll stop talking now.
No. So it's absolutely fascinating, and I'm sure we can go on for a long time. But we are out of time, alas. But I'll have to stop over here. But Tom, thank you so much for making some time and speaking with us. We definitely hope to see you at Bayes Business School very soon. And for everyone, please do have a look at Tom's new book, which is How to Read Numbers. Thank you so much, and thanks everyone for joining. Thanks.
Thank you, guys.